Y bueno, estaba programado que el arquitecto Michael Hopkins estuviera con nosotros, sin embargo, por alguna razón no pudo estar con nosotros, pero tenemos al arquitecto David Selby, que es de su despacho, y primero haré una presentación generalizada de Michael Hopkins Arquitectos y Asociados. El arquitecto Hopkins es un arquitecto inglés que fundó este despacho en 1976. Es una firma que ha impulsado el diseño arquitectónico, innovador y en particular aquellas cuestiones relacionadas con el ahorro energético. Entre las obras representativas, que la mayoría se encuentran en Gran Bretaña, destacan la Casa Hopkins en Hampstead, el Mount Stand en Lord Cricket Ground, un hospital infantil Evelina, Casa Portcullis, entre otras, que están en Londres. Algunos de los principios que nos parece interesante mencionar acerca de esta firma de arquitectura es que ellos producen arquitectura ambientalmente responsable, con cuestiones relacionadas, como ya mencioné, del ahorro energético, materiales, reciclaje de materiales, rehabilitación histórica, cosecha de agua pluvial, cubiertas naturadas, materiales reciclados, recuperación de calor, prefabricación, geotermia, luz natural y madera producida social y ecológicamente responsable, por aquello de la pregunta de la sesión anterior, y así como la revitalización de sitios contaminados en abandono u ociosos. Tienen oficinas no solo en Londres, sino también en Dubái, en Tokio y en Múnich, y bueno, agrupan más o menos alrededor de 70 arquitectos. Bien, pues muchas gracias. Thank you, David, for being here, and we are very glad to have you here. So, go ahead.
Thank you,
please.
Alessandro. Firstly, I wanted to say that I'm sorry that Michael Hopkins couldn't be here this evening. He was very disappointed he could not attend. For health reasons, however, he has been advised not to take long-haul flights for the time being, so maybe he will come another time. He sends his sincere apologies. I, on the other hand, am very pleased to be here instead. Okay, this is our beautiful Velodrome building, the Olympic Games Velodrome. I will come back to that a little later. It's one of our favourite projects and most publicised projects, so it was really good for us. Okay, this is Michael Hopkins. I've actually been working with Michael since 1984, so we're not exactly brothers, but you know, we're pretty close, and I hope that this talk this evening will convey some of his emotion and compassion for architecture. In 2011, he was given a Lifetime Achievement Award for his services to architecture. The quotation from Paul Finch, a well-known journalist in the UK, is listed there, that it's really talking about the practice which Michael was the founder of, that we are working really as one, not as just a series of associates, and that after a very long time we are still successful, unlike some others, and that we approach our work confidently in a manner rather than a specific style, an approach rather than a formula, and doing so both at home in the UK and also across the world. The work of Hopkins when Michael was a young architect and I was probably a young boy. There was a belief, however, amongst modernist architects is, I believe, identifiable for its holistic nature of design and architecture. Sustainability has arguably always been present in its work to a degree, a greater or lesser degree. We have not always described it as such. Sustainability, as we understand it today, was not so much a concern for architects in the 60s and 70s. that technology could solve the problems of increasing world population and depleting resources. Yet, do not the principal tenets of modern movement, followed by so many of that era, functionality and the idea that architecture could embody economy of means in planning of architecture and construction of buildings, seem on the face of it to anticipate in some way sustainable design? Question mark. What I would like to show you today is how, in the context of its history, our architectural studio has developed ideas of sustainability in the broader sense of architecture, bringing together context, built form, materiality, purpose, and planning. It seems to us to separate somehow sustainability as a separate discipline rather than an integral part of building appears a false notion. Architecture and the appearance of buildings should reflect all aspects, including an approach to environmental systems, whether active or passive. I hope to a greater or lesser degree you will see this in the examples I will show you related to the evolution of such ideas in practice. Okay, our story begins in the English countryside, at a house that Michael Hopkins bought as a young man. The 400-year-old house was a complete wreck. However, Michael saw that its crafted timber structure clearly appealed to the young couple, Michael and Patty Hopkins, in its simple yet purposeful design. This was arguably, I suppose, the first project in the office, even before it really existed as a practice, when Michael and Patty Hopkins were themselves working for other architects. Going back to the timber frame and the structure, each part of this timber frame was carefully sized according to its span and its purpose, and was connected with simple but effective timber jointing techniques. In its refurbishment, the house was sympathetically remodeled using original techniques to preserve its frame and to create a series of living spaces which, when viewed in plan, have more than a passing reference to the plan of the Farnsworth House by Mies, a totally different context, yet demonstrating an interest in adapting existing buildings to modern use, in itself now recognized as a notion of sustainability, and which was talked about by Michael Schumacher just before me. This attention to detail, although you see it in its refurbished form, they no longer live in the house, but it's still there in its refurbished state in Cratfield in Suffolk. This attention to detail can be seen in the modern house which Michael and Patty subsequently built in Hampstead in London. This building, this house, was an exercise in minimal design in many ways. A very fine grid of small section steelwork where each part has a job to do and is designed specifically for the purpose. Economy of means again. No waste and totally simple detailing. A flexible and open interior. The resulting home served them well as an office as well as a home, accommodating 3 children, and which they still occupy themselves today. A simple expression of a lightweight solution which has a synergy with the house of Charles and Ray Eames they so admired, and allowed them to experiment with techniques later used in larger projects. The house remains largely unchanged since it was built in 1975, except for the introduction of double glazing and the provision of improved insulation. A series of projects then followed that explored the application of these ideas to larger projects, such as a beer cellars project for the brewer Green King. The modular system for light industrial workshop and studio use, known as the Patera system, was another example, which I will show you later. Green King was a very process-driven design. Used beer barrels were returned to the building at one end. They were washed, filled with beer, and collected by lorries at the opposite end for delivery to the local pubs. It allowed the practice to develop engineering and architectural solutions to wider spans in an equally expressive way, and recognizing that economy of means can lead to elegance in the most utilitarian of buildings. The Patera building system around about 1970, compared with the Green King project, which utilized many off-the-shelf materials and products. The Patera system, I'll never know whether this is named after Michael's wife, Patty Hopkins, but anyway. The Patera system was really a complete bespoke solution, designed and engineered for mass production to suit a number of potential uses and sites. For this reason, the economic use of materials was a critical factor in the cost of production of such a system, as was the ease of construction itself, so that given a reasonably flat concrete base, the frame and envelope could be erected by a small team. Here you see the design of the modular system and the panels themselves. The trademark Hopkins lightweight external steel frame minimizes the actual building volume, saving heating costs and fire protecting the external steel. The cladding is modular so that the wall and roof panels are interchangeable. The inherent flexibility and capacity to erect, use, and disassemble and reuse in a variety of locations were key drivers in this design. Was there, I wonder, an agenda for sustainability behind the reusable nature of this design? Perhaps. A number of these buildings were made during the 1970s and early 80s. A special version was built as the studio for our practice in London, which it has done since 1984. Moving up a scale at the Schlumberger Research Building in Cambridge, near Cambridge, the research building took the application of large span structures in a new direction for Hopkins. The engineering of stressed skin fabric structures was to become a fascination for the practice to be developed over many years. This minimal and cost-effective approach to achieving an envelope for weather protection of large spaces, utilizing high-strength glass-reinforced fabric, allows light transmission and produces a very sculptural architecture. In the case of the Schlumberger building, this is to enclose large spaces which were used for the testing and simulation of drilling rigs and for the provision of social spaces for staff welfare and restaurant areas. The theme, economy of means, could be said to run through this project to some degree, although the materials had a relatively high embodied energy content. They were used sparingly and in a functional yet expressive way. This project pushed us to explore these new techniques, and in doing so identified us at the time as a member of a group of architects known as the British High-Tech Architects. The Mound Stand, Lord's Cricket Ground, London. I don't know how many of you play cricket. A lot of people play it across the world. We have built many cricket stadia, including 60,000 seat stadia in India, where it's almost a religion. Lord's Cricket Ground in London is acknowledged by many as the home of cricket. At Lord's, each stand is different, and the Mound Stand is one of its oldest stands. Our task was to bring new life to the old stand. Rather than replacing the old brickwork stand, which you can see here, we saw in that stand an elegantly engineered brickwork structure that, if extended, could form an architecturally stronger solution above which a new modern stand could be constructed to provide the much needed hospitality facilities to bring a new revenue stream to the Lord's ground. This is an example again of utilizing an existing building and its original technology to extend its life. New brickwork arches were built to form a colonnade, above which a new steel structure was constructed with minimal supports to maintain the sight lines for watching cricket. The use of fabric here was to provide a lightweight covering to the upper levels and gives the stand its distinctly summery feel. Contextually, we felt this was an appropriate response to both to the spirit of the game and as part of a group of iconic buildings which has now given Lord's its distinctive identity. This growing fascination with traditional brickwork building techniques was utilised at Glyndebourne Opera House, where we replaced an existing auditorium with a much larger opera house for summer events that are held here in the Sussex countryside. This was not, however, brickwork used as cladding, but as a load-bearing material, as it's supposed to be used. The study of traditional building techniques for large brick structures, such as here at the Maltings in Colchester, were applied to the new opera house, and again give an architecture that has grown out of its context and with careful modelling of the exterior achieves a scale in keeping with the original house. Fabric structure as well there. All bricks were uncut except where necessary to achieve the traditional brick bond techniques to reduce waste. Recycled pine timber was used in the interior. So careful use of materials and form gives new life and identity to an established opera venue. Okay, The Hopkins house in Italy, near Lucca, is another example of traditional construction where, like Cratfield, the materials could all be found within 20 miles of the location. This idea was both a source of fascination of interest, but in the current day is quite a challenge. However, like Cratfield, its restoration was true to that principle. Okay, Inland Revenue Centre, Nottingham, UK, completed approximately 1995. This principle of acquiring materials locally was also explored for this building on quite a different scale, for a project to provide office accommodation in Nottingham for the government's tax inspectors, where materials were sourced locally or at least fabricated locally, and once again the context suggested the solution. Initially, in the planning of the site, not one large building, but a series of buildings and streets in scale with the context, and which were conceived as part of the city, focusing on the local landmark of Nottingham Castle. There was also an economic reason for this, that dividing the project into a series of blocks would also enable the disposal of any building that became surplus to requirements. But also the idea of the choice of materials came from the context. Nearby warehouse buildings of the 19th century were constructed of masonry and load-bearing brickwork using local bricks. This was a source of great excitement in the office, believe it or not. We therefore evolved a system which was equally true to materials, utilizing load-bearing brickwork piers. Our brickwork piers were fabricated in a factory, as were also the large precast floor units, all within 20 miles of the site. I should probably add at this juncture that a lot of the development of buildings by Hopkins was done in conjunction with the London office of Arup engineers. You'll have met Bruce yesterday. And he's here now, so that's for you, Bruce. Okay. Efficiency of structure suggested that the size of brick structure should increase to accommodate the increasing load as it accumulates towards the base of the building. Materials used according to purpose again and where required. This was strategic for a number of reasons, and also articulates the facade in a more meaningful way. Prefabrication by making the brick piers off-site saved months of construction time, very important for the short programme. This project was the first BREEAM Excellent project in the UK. I assume you know about BREEAM being the recognised method of assessing buildings' performance in energy terms. Excellent at the time was a very high standard. The heavy structure of brickwork and concrete floors was an essential part of a passive rather than active approach to energy reduction. Incoming fresh air was used to pre-cool the building's structural thermal mass at night, giving capacity to absorb heat gains in use during the day. The piers and shading devices that you will have seen on the facade reduce solar gain, while light shelves help project natural light deep into the building. In the summer, when it gets hot, the incoming air, which is obviously relative in the UK compared with Mexico, but the incoming air can be cooled. Incoming air. To protect, can be cooled, and as the building heats up, it is vented. You can see that the cool air coming in, absorbing the heat gains in the space, rises, and it heads towards the stair towers, and it's vented into those stair towers where the hot air is exhausted by literally raising the roof. These devices here are actually rams, hydraulic rams, which are used mainly in stage techniques. We learnt this on Glyndebourne, and they are then used to push up the roof and vent the hot air. So, carefully engineered contextual materials can utilize primarily a passive approach, and this summarizes really our proposal for sustainable design at Nottingham. And I suppose at that time, that was probably the first consciousness of creating a cohesive, sustainable architectural design. This is a summary slide of basically what I've just said, so I'll pass over that. Okay. Portcullis House, Westminster. This building was completed after the Inland Revenue project. This was completed in 2000, but these ideas were developed together for both projects. The design of Portcullis House and the variation of the Inland Revenue project evolved out of what we thought at the time was pretty serious research carried out with O'Varup and partners. Not just architects' research then, but also with engineers, measured research involving the building and testing of prototypes and the publication of that research, all made possible by European Union research grants. So now we're really getting to some serious stuff, especially as this research was being undertaken in the 1990s and is now, in many ways, fed into the ideas that have become more mainstream in sustainable design. Some brief facts about Portcullis House. Oops. Sorry. It was conceived as accommodation for 200 members of Parliament. It's located next to a landmark building that most people know worldwide as Big Ben, part of the Westminster Palace. It was built in the form of a courtyard building with individual rooms around the perimeter. Other conference and committee spaces are provided at the first floor. The central courtyard was covered and provided entrance space and communal facilities. It was built over an operational railway while the new Westminster Underground station was being constructed for the Jubilee line extension, which we also designed to make sure the columns connected in the right places, which in themselves have a story associated with them. The primary supports running directly through the main escalator box of the station itself from the building above. The design of individual rooms for members of Parliament was informed by the research programme, and by its repetition forms the essential cell of the whole building assembly and its architectural composition. This diagram explains in principle how each room worked in terms of its environmental characteristics. Thermal mass is provided by the soffit, these large precast concrete panels that you saw at Inland Revenue. There is a sort of sister of them used in this building. The walls between rooms were also made of concrete and provided additional thermal mass. Hot air was delivered by facade ducts, cool air was delivered by facade ducts entering the floor void, guided into the room through floor grills, and in the space the temperature rises of that air, and by simple displacement ventilation technique the hot air rises into the top of the room and is extracted through the facade ducts again. Light shelves created solar shading for the window area, but also reflected, again, daylight into the middle of the room, thereby reducing the extent of artificial light required. The facade ducts themselves run up the building on each side and collect in the roof plant areas where a thermal wheel would either cool or heat the air as required, and exhaust air was expelled through these large chimneys, which give the building its sort of character in terms of the skyline of London. These ducts, which collect the facade ducts, become roof ducts, and this spider-like configuration is actually supporting, they are structural and they're supporting the rooms and the plant areas in the roof. Here you can see the same principle of load increasing towards the base of the building, and these stone piers, and these are actually load-bearing stone piers. The only metal in them is a rod which is used to lift these piers into position on site. There's no reinforcement, it's just solid stone. So this building really rewrote, if you like, the structural code for design of stone building on this scale, which is quite an achievement when you consider this whole building is supported only by stone. There aren't many modern buildings that do that. You can also see that there's an inverse or reciprocal relationship between the facade duct geometry, which gets smaller as it comes down the building away from the roof plant areas, in relation to the also largening, the increasing size of the piers, to create a sort of integrated, if you like, services and structural zone between which the windows are placed. You can also see the distinctive light shelves, which also give it its three-dimensional character as a facade. Really quite a controlled approach, an integrated approach to the elevational composition, deriving entirely from the functional requirements, with a bit of architecture as well. The stone was quarried in Derbyshire in the UK, and the stone piers were fabricated within the quarry and then transported to site on lorries, a little bit longer and a little bit further than the 20 miles, but it was a UK-based operation. Unlike the precast concrete floors, which were fabricated in Belgium. Now, really, the limitation on sticking to our principles of local design and local materials had to be broken because of the requirements of the European Union procurement rules, where contracts had to be thrown open and available to the whole of the EU. Hence, Belgium was chosen as the most economic site and source for the precast concrete slabs. The bronze used for the facade and the roof was, however, fabricated in the UK. Interestingly, it was fabricated by a company called Alvis, which used to make cars and now make tanks, and were very specialised in the use of exotic metals, as we call them. Bronze was chosen for its sustainable, long-lasting and durable quality, recognising that it has a very high embodied energy content in itself, but that it would last a long time. And part of the brief for this building was to achieve a lifespan of 200 years or plus. Again, that's just really what I've talked about already. I won't go through that list. The overall design was conceived to be in keeping with the adjacent World Heritage Site at Westminster, and I think you'll agree it fits in. I hope you would agree that it fits it very well. Architecture, again, as an integration of the building's sustainable features, utilising traditional materials in a modern engineering solution. That was, of course, a very special project with, some people would say, a very special budget as well. In the due course of time, this project was interrogated by what we call the National Audit Office and proven to be value for money. I think after many different opinions about its external appearance and the cost, people now recognise, 13 years on, that it actually is a building of quality, and the members of Parliament all enjoy working in the building. Okay, from London we go north again, once more to Nottingham and the Jubilee campus. This is a university campus. The brief was for a new campus for 2,500 students on the site of a former bicycle factory. 2,500 doesn't sound a lot compared with your university here. Okay. I don't know how many of you use bicycles, but in the UK, for a long time, that was a preferred method of transport, and I think it's coming back. But there was one trademark name which was known above all others, called the Raleigh bicycle. Now, Raleigh sourced their materials from the Far East now, so they had no use for the factory, which was sad, but also represented an opportunity for Jubilee campus to be built. A Serpentine Lake was created following the line of the only remaining feature of the site once the factory was taken down, this belt of trees along this side. Along that lake were arranged the principal faculty buildings, a learning resource centre and central teaching building. So here you can see the learning resource centre, which is a sort of inverted cone, a sort of spiral, interestingly. So there was a sort of continuous circulation, quite an interesting idea. The central faculty building was here, other teaching blocks here, and of course the lake, and some student residential, more student residential here. Water. Sorry. A colonnade on the front of the buildings forms both a connection between these buildings and a link within the overall campus, leading from playing fields to the main existing campus. It has views over the lake and gardens and engages with restaurants, shops, and other meeting spaces at the ground floor level. Here you can see the lecture halls. These are lecture halls stacked one above the other, the smallest at the bottom and the largest at the top, to create purposefully space at the ground floor level around which people can meet before they go to their lecture. In terms of the overall master plan, the lake had an importance not just as a landscape feature, but to collect water, and in doing so create a cooling benefit, helping to cool the prevailing wind that in turn assists with the cooling of the faculty buildings. Sedum roofs, which is a type of grass, provides biodiversity and adds to the overall landscape concept of the scheme. Now, this was a university project on a budget. This was probably one of the lowest budget projects we've ever done, certainly at that time. The program and costs were so constrained that the constructional technology was forced to be as simple as possible, the emphasis being on refinement and rationalization of detail. So the main 3-story buildings have simple in situ concrete frames, providing thermal mass again to assist with the cooling. These frames are clad with a modular system of prefabricated timber panels and openable windows. And I refer to the question made to Michael earlier about the use of timber, which in the UK's sustainability guides gets a sort of AAA rating, really. So I think in the context of sustainability, certainly we understand it as being a good material to use, but obviously recognising that it has a limited life, but then it can also be renewed and replaced. Full height sloping glass atria supported by laminated beams create interstitial spaces between the faculty blocks. This larger one serving for the purpose of the university refectory, the campus refectory. A low pressure drop ventilation system, again with the cooling and benefit of the lake, uses corridors and stair towers as air plenums, reducing the energy needed to circulate air and to cool the building. The stair towers are a development of those at the Inland Revenue, utilising the staircase as a duct for extract, but with rotating cowls which respond to the prevailing wind direction. Under normal conditions, the wind is enough to exhaust the air, which is again subject within the building to this low pressure differential effect, and the sort of and the effect of buoyancy within that system. During hot weather, the photovoltaic cells, which are used to provide solar shading over the glazed roofs between the blocks, creates and generates supplementary power for fan-driven ventilation. So, in terms of our sustainability timeline, the campus project was an opportunity to expand our thinking in terms of master planning a whole complex of buildings, to take advantage of site features and planning, and to maximize the sustainability opportunities of a project of this scale. The buildings themselves are modest. Planning and form are primary considerations. Active measures were kept to a minimum, and the energy consumption, for anybody that can read this slide, indicates that the consumption was less than half of that of a best practice building of that time. Best practice building now are considerably different. And you see it at night, and obviously the effect of reflections on the lake give it a particular and very attractive appearance. Okay, we go over the pond to Yale Forestry and Environmental Studies building, which was located behind an existing 19th century stone faculty building, quite a domineering building, behind which a backland area had developed and deteriorated over a period of time to become a dumping ground for materials and unwanted stuff, basically, from this and other departments around, with the effect that it pulled down the quality of the area, and several adjacent buildings also were pulled down in quality. Generally, it wasn't cared for and it wasn't loved, and it was really a waste. Our job was to find a solution which breathed new life into this area, as well as creating a new forestry and environmental studies building. So this was an opportunity to introduce a new building, loved space. These spaces have now become places for people where students gather and move from one building to another. People seem to take pride in them, and they are kept in a reasonable state and condition. It goes without saying almost that any building for a school of environmental studies should be and should have a very high energy and sustainable credential. And the features of this building are many, and achieve a rating of a LEED Platinum building, and 50% or greater reduction in energy consumption and carbon emissions. The use of timber throughout the interior. The use of timber throughout the interior gives it a particular character. And the students seem to like it. Okay, moving on to Princeton, the Frick Chemistry Laboratory in New Jersey. One of the aims here was to design a building that set a new standard in energy efficient design for chemistry research buildings in the US. This is no mean feat, really, quite difficult for a building so full of highly serviced research equipment. The outcome is a project that incorporates a number of sustainable features, including one of the largest integrated photovoltaic arrays in the US at the time, a pre-manufactured energy-efficient facade, grey water recycling, chilled beams, and extensive use of natural lighting, coupled with daylight sensors throughout the interior. In a way, I suppose, the danger was that this building was becoming a bit of a machine, and its exterior is a particularly functional solution architecturally in accordance with its sustainable goals. But it has people spaces too. The central atrium, which runs through the building, gives it its natural light into the interior, becomes at once a route through the building and a space for events and gatherings. Okay, we're moving up to date now with two buildings which are civic buildings, both in London, which are local administrative buildings for two boroughs, the Hackney Town Hall and Brent Civic Centre. These two projects reflect the brief of local authorities for new buildings that help them rationalise and improve the provision of services to the public and set high standards in civic design and sustainability. At Hackney, as this slide shows, the BREEAM Excellent building demonstrates a significant reduction in carbon emissions and in energy generation. This is achieved by providing a combination of gas and wood pellet boilers, as well as a large photovoltaic array on the atrium roof. That's all right, I'm fine, thank you. Thank you. The open atrium is in itself now a major space, a major public space for the borough. It relates and visually locks on to the existing town hall beyond, where the ceremonial functions still take place. The floors around the atrium are constructed in concrete. Again, the thermal mass is used to control the heat gain and absorb the heat. The open atria, quite unusual in a building of this size, facilitates a natural stack effect and serves as the return air path for the mixed mode ventilation system. And it looks pretty good, a good modern building for a good modern local authority trying to improve their position. The second of these buildings is at Brent Civic Centre. I don't know if, I'm sure there are people here who play football. I've seen them playing outside. This building is located next to Wembley Stadium, and if you've been to London, you might have gone to a concert at the arena, London Arena. So this building is placed strategically, if you like, in a very important position in relation to the Brent Borough as a whole. The Brent Civic Centre will be our first BREEAM Outstanding building in the UK, and all the indications are that it will set the highest standard for sustainable design for a local authority building. When complete, the key sustainable features, which include a combination of solar shading, natural ventilation, high-performance facades, and combined cooling, heating, and power, utilizing fish oil, will contribute to that outstanding rating. It will also, because of its strategic location, kickstart an area of regeneration in Wembley that has previously remained underutilized for many years, despite the football. It will create a new cultural and community focus for local residents. Both these buildings allow the consolidation of real estate where local authority administrating is and functions have grown up in several locations across the borough. These can now be consolidated into one efficient location, and that these buildings are also sized to take account of new ways of working. So not everybody is in the building at the same time, so why build the building for everybody if some of them are out working outside, some of them are working from home. These new ways of working promote the efficiency of these buildings and allow them to be sized accordingly, achieving significant financial savings for the community. And there it is on site at the moment, due for completion later this month. Okay, well, we're back to the Velodrome. Now, this is one of the pursuit bicycles. The bicycle, over time, has become a very refined machine, light, efficient, and geometrically well developed. In designing the 2012 Velodrome for the Olympic Games, we set out with the intention to build a building that reflected these principles. The building has achieved BREEAM Excellent rating and encompasses many sustainable features in the design, but as I've attempted to set out, design is more holistic than that. It's not about ticking boxes, it's about squeezing as much as you can get out of a project. In this particular instance, we were striving to achieve the lightest possible solution to the roof structure. Many of you may know about the work of Fry Otto many years ago, actually, in his stressed structures, stressed skin and rut structures, and in a way we were following that clue, if you like, to a degree, in order to set ourselves a goal of achieving this highly sustainable solution with a totally minimal approach to the roof structure. The design, if you like, of this structure, which each of these is a pair of 40mm diameter cables. This design evolved out of modelling, simulation of various geometries. You can see from this simple graph how the span and the modelling of the roofs significantly affects the weight of steel in the roof. The double curvature is by far the most efficient shape, and we chose to adopt that form in developing the roof of the Velodrome. Even so, the refinement of that went on to save 1,000 tons of steel in the roof compared with a traditional solution, and reduce the program by up to 3 months, which was pretty important because the building had to be finished for the Games. The resulting form also facilitated benefits in terms of the air extraction patterns and created a low building envelope ratio to the building size, building footprint size. we're pretty pleased with the solution, and we were very glad to win some gold medals at the game as well for the cycling within this building. This is one of the buildings which had a clear legacy to it. There was a cycling club on this site before works began, and that cycling club will occupy and use the building, which will no doubt also be used for national events. Okay, in conclusion, I think it's clear that sustainability is not a separate discipline or something that the engineer applies to an architect's design to make it work. It's something, we believe, embodied in the thinking and integrated into the final architectural solution. It entails consideration of the broader aspects of the project, of planning, regeneration, of contextual considerations, of material and technology choices relevant both to the context and the demands of the program, and recognizing the broader aspects of energy generation and the need for reduction of carbon emissions. BREEAM and LEED have become the mandatory codes, and many projects are simply about fulfilling the code within the project and within the budget for projects. The architect's role is really to see beyond the codifiable and the mandatory, to consider the many strands of sustainable design that create joy in our spaces and places, in our architecture and our environment. Thank you.
Bien, en lugar de pasar a las preguntas y respuestas que tradicionalmente se han estado haciendo en las sesiones, a sugerencia de la organización haremos una especie como de reflexión, aprovechando la presencia de los tres ponentes extranjeros, y haremos una serie de preguntas, esto inspirado en un libro que se intitula 12 entrevistas con arquitectos, bueno, aquí habrá 5 en realidad, y que se hizo, fue una experiencia que se hizo en Chile, a cargo de Fabio Picci, y bueno, entrevistaron a Norman Foster, a Richard Rogers, a Toyo Ito, Bernard Schumi, Daniel Ipskan. Bueno, ahora tenemos a estos arquitectos que los invitamos a pasar y haremos esta dinámica para poder aprovechar a manera, digamos, de reflexión con respecto a lo que se ha visto hasta ahora y aprovechando la presencia de ustedes. Bien, sin embargo, antes de ello, no sé, perdón Héctor, si le entregamos ahora su diploma o esperamos hasta el final de la sesión. ¿Perdón? Sí, ¿verdad? Bien. Well, meanwhile, while the others come here, we'll give you a constant. I'll say it in Spanish, please. Pues agradecemos la participación del arquitecto David Selby en este 8º Congreso Internacional de Bioclimática y Diseño Sustentable, cuya temática se basa en los 4 fundamentos en la arquitectura sustentable, del 4 de marzo al 7. So this is for you to like recognition, yes. And within this 8th Congress International. Thank you very much.
And I'm very proud to have attended your Congress. Thank you.
¿Iniciamos ahora o damos un...? ¿Sí? Ok. Bueno, entonces, we invite Bruce to come up to stage, and also to Michael. I don't know if Michael is here. Yeah? Yes, he's here. Raúl Huitrón, ¿sí? Y a Héctor Ferreira, por favor, ¿no? Raúl. Perdón, las preguntas se van a traducir y se van a hacer llegar, en este caso a David Selby, y él las contestará. Posiblemente al final de la sesión, quien haya hecho las preguntas, pediremos un correo para que él pueda contestar sus preguntas directamente a cada uno de ustedes los que han hecho las preguntas. So I'm suggesting that the questions of the public will give them to you and with their email, and if you can, after, whenever you can, to answer them, yes? Bien. So to start with a kind of reflection, and we'll give you here one question to start with. Well, no, it's not me, but one of the architects couldn't be here. But well, one of the questions would be, where does sustainability begin? When it begins, yeah.
Obviously with me. I think you described it best and very carefully, actually. I think sustainability, for me, is not so much to do with BREEAM or DGNB or LEEDs or this. For me, sustainability is a sort of attitude towards a problem of organizing space in which scale ever. I mean, it starts in town planning, it goes into detailing, it's a way of thinking, and obviously in the last 10 years since it became a topic, a political topic. Yeah, I mean your office and ours, a bit younger, and Foster's and others, and Buckminster Fuller, and maybe somebody we all see as a sort of father or so figure in that movement. We always had thought about sustainability before they even invented this expression. Yeah, and now it became a wide topic, and sometimes I'm afraid the more we talk about it, the further it goes away in architecture. But to take it serious, I think it's an attitude, and the attitude is not only about CO2 or sometimes in Germany it's in some aspects also ridiculous. I mean, you can fulfill these DGNB or BREEAM sometimes with things which one can't believe, actually, since it's only a list of things. But nevertheless, I'm sure that the fashion about sustainability created a pressure on developing it in a concentrated and further way. But in the end, it is a way of thinking, an attitude, a personal attitude of all of us.
Well, yeah, I guess, with the three people here and, the basis of our firms and the firms that you started with Foster's, I believe sustainability starts with, the first principles of design. And in addition to that, the recognition of how collaboration and integration of design can take you, and then can inspire your clients at the same time. And what's really exciting for me is, I think what David said, it can't be clipped onto a project or just added onto the project. It's about starting at the beginning and really working together, because that's where the real sustainability comes from. Unseen, passive, it's integrated into the project. And so the answer that I would have, it starts with the first principles of design.
Thank you. I just wanted to recall, really, when I was a young student, working for a very thoughtful architect at the time, not particularly well known, but when he sent me off to university, he gave me a book, which was a book about the history of architecture, called the Bannister-Fletcher book, written by Bannister-Fletcher. And it encompassed, if you like, many different styles, and simply calling them styles seemed rather odd, because they all grew out of their different cultures
and the different needs. But when he wrote something in the front of that book, and what he said was architecture is not just about thinking with the head, but also with the heart. And I think it comes down to an attitude about your fellow human beings and how you relate to them, whether you care about them, what your priorities are. If you want to make money and produce good architecture, well, you know, you'll produce a certain type of architecture, possibly. But the priorities are not necessarily entirely commercial. They are to do with leaving, if you like, an architecture and a contribution to our built environment that actually is a lasting contribution which people will enjoy, respect, and keep, I think. The many historical buildings that you have in this city are a testimony to that, and I think there's a common thread that sort of runs through it, which is your attitude towards the past and your attitude towards your fellow human beings, which it sounds really rather cheesy, but you know, we have to have an attitude towards our work and thinking about projects, having a great idea. Sustainability has to be a priority and go right to the core of any project and any idea which is the foundation, if you like, of any project. So, you know, I think even more going forward, it's totally unavoidable. You have to think of it as a priority at the very earliest stage.
Bueno, quisiera platicar muy rápido sobre esta dinámica, porque me parece muy importante cómo podemos tener puntos de vista similares, pero no necesariamente, y esas diferencias también nos hacen aprender. Este libro de 2 entrevistas con 12 arquitectos principia con la idea de 2 jóvenes arquitectos, bueno, un chileno y un argentino, y le hacen exactamente la misma pregunta a estos 12 arquitectos. Lo interesante es que hay algunos ejemplos, como es el caso de Norman Foster y Richard Rogers, que trabajaron juntos, hasta tuvieron un despacho que se llamó Team 4, es decir, el equipo de 4, porque estaban involucradas también sus esposas. Pues obviamente terminó el despacho al poco tiempo, pero finalmente cualquiera podría pensar que tienen ideas muy afines. Entonces de pronto había algunas preguntas donde brincaba con sorpresa de que contestaban cosas absolutamente y completamente opuestas. Entonces es la intención de ahora el hacer una sola pregunta y que todos tengamos oportunidad de responder y que no necesariamente deban o puedan coincidir, y si coinciden, qué maravilla. Yo nada más quisiera decir una cosa desde mi punto de vista como arquitecto mexicano, y que todos los días busco una oportunidad para poder convencer a nuestros clientes, cualquiera que sea, si es gobierno o iniciativa privada, de que se haga este tipo de proyectos. La pregunta se refería más que a la actitud, es de dónde cómo principia la sustentabilidad. Creo que hay una palabra que a lo mejor no la hemos explotado lo suficiente, aunque es bastante obvia, que es la palabra historia. En el momento que entendemos la historia del lugar, por ejemplo, David lo presentaba en el primer proyecto en la casa que adquirió Sir Michael Hopkins, que tenía 400 años, por cierto. Entendieron la historia de esa casa, entendieron la historia del clima, la historia del lugar, la historia de cómo ha venido evolucionando incluso desde el punto de vista urbano. Aquí tenemos una serie de coincidencias con lo que presentaba en la primera conferencia Sarah Toppelson hablando sobre el sitio, etc. Entonces, en mi opinión, la sustentabilidad empieza con entender la historia de más que de la arquitectura de ese sitio, con todo lo que esto representa. Y por otro lado, lo que esto se refuerza a nivel de una filosofía de despacho, como es el caso de Bioma, es que siempre existe, bueno, nosotros tenemos una máxima que dice que un edificio o cualquiera de nuestros edificios tiene que ganarse el derecho a existir. Y para que se lo gane, precisamente tiene que responder a esas consideraciones de la historia. Y es donde para nosotros principia la sustentabilidad.
Thank you. I'll just give a an opinion about what we were saying about where sustainability begin. And I think with the regional or local nature and culture observation within the site we're going to build something, it's a good start. I mean, perhaps here in Mexico and within the architectural training, that's not very common. I mean, just to observe, but they observe the nature as natural forces and the culture either regional or local. And I think that could be a good beginning, and that could give us also a different attitude, the ones that you've been talking about. Okay, well, a second question would be for you, which are the most significant resources where sustainable architecture emerges? Yeah,
So the question is, which is the most significant resources as it relates to sustainability? And you know, my argument is to a lot of my clients who sometimes say, why should we pay for this? And I think it's the human cost and what the built environment can do for productivity, for improved lifestyle, greater health. And I think we sometimes lose track of that when we talk about sustainability, because we put it in terms of carbon, energy, electricity, water, which are all very important, but we can't lose track of the benefit to the built environment in terms of how buildings are used and how buildings are lived in.
I would actually say that it really does depend where you are as to what resources are the most important. And I mean, I think we've talked about resources and solution to minimizing the impact on resources quite a lot this evening. But I think for the future, one of the key resources that we all need to preserve is water. I think that is going to be a significant resource in the future if we consider that we will grow as a world population, that we have global warming, we have other issues that will deplete potentially our water resources. Saving water would be my priority for the future.
To bring another idea to this discussion, I mean, in the last years, sustainability was always related to CO2 and materials and you say human resources. I think that's all right. But I think, since we are architects, space, to organize space for a lot of people in a fairly dense way. I was in Mexico City. I learned today Mexico City with 20 million inhabitants is the same size as Berlin with 3 million people. Obviously, it's a bit too dense in some parts for my taste in Mexico City. But nevertheless, the question of organizing space, which is a normal, that is what we deal with as architects. We organize space. The middle-aged city, which organized space for protecting from enemies from outside. I think that part is, for example, in all these certification stuff, non-problem. Yeah, I think I have to say that here with architects, that I think to organize space is for me one of the main resources of sustainability, looking at the project as an architect. And we should give that more. It should be what we do best, really. Yeah. Yeah.
Es una pregunta muy general, y creo yo que una pregunta general pues también nos lleva a tener una respuesta general. ¿cuáles son los recursos? ¿Dónde principian los recursos? Finalmente, ¿qué fue primero? ¿El huevo y la gallina? Son todos los recursos al mismo tiempo. Me cuesta trabajo pensar que solamente pensemos en los recursos renovables, que solamente pensemos en los recursos financieros, que solamente todo es al mismo tiempo. Lo que sí he tenido oportunidad de capturar cada vez que tengo el placer de convivir de manera personal o trabajando con gente como ellos y otros arquitectos mexicanos de los que he aprendido muchísimo. Una vez me dijo Agustín Hernández que después de una severa crítica que le hicieron sobre si era muy formalista su arquitectura, etcétera, me dijo: Raúl, ¿tú crees que un avión es formalismo? Bueno, pues sí me gusta el diseño del avión, pero en realidad no está diseñado así porque se vea bonito, sino para que se eleve ese pajarraco. Tiene que estar diseñado en función de cómo van a estar trabajando las turbinas, la posición de las alas y los alerones, si no esa cosa no se eleva, aunque sea muy estético. Entonces eso para mí se convirtió en una generalidad, donde finalmente tenemos que llegar a un punto de equilibrio para que nuestra arquitectura se eleve, es decir, para que nosotros podamos construir lo que tenemos pensado. Si tenemos un proyecto donde entendemos muy bien los recursos naturales, la historia, etcétera, pero es prácticamente impagable, porque recuerden que estamos en México, donde nuestro principal dolor de cabeza es el recurso, y tenemos que hacer mucho con poco. Si no tenemos la capacidad, o mejor dicho, si no tenemos la intención, es la mejor palabra, de tener ya sobre la mesa no solamente qué es lo que se debe hacer, sino cómo y con qué recursos, donde no necesariamente, si eso se trata del gobierno federal, tenga solamente absorber su erario, sino que ya se plantea toda una propuesta financiera, es mucho más fácil. Entonces yo creo que son muchísimos recursos los que intervienen al mismo tiempo.
Bien, bueno, yo quisiera decir que, bueno, me refería a recursos significativos y esto es una cuestión, digamos, como para reflexionar acerca de lo que a veces en el campo de la arquitectura no se toma en cuenta. Todo proyecto se sitúa en una posición física, en donde existe un antecedente, y ese antecedente a veces nos remonta a miles de años atrás. Si nosotros hacemos, por ejemplo, un análisis geológico, pues vamos a encontrar milenios de historia geológica detrás de un sitio. Y bueno, eso creo que debería de atenderse más desde el punto de vista sustentable, es decir, ver aquellos recursos ambientales, sobre todo, de paisajes previos a donde vamos a actuar como arquitectos, y esto implica una escala del tiempo, es decir, habrá que hacer un ejercicio para ver qué es lo más significativo dentro de la evolución de un espacio, el cual se va a intervenir en un momento actual. Por supuesto, este es parte de un proceso que es en ocasiones bastante complicado. Sin embargo, creo que en lo futuro se deberá atender un poco más hacia esas cuestiones y tener una idea más clara acerca de esa evolución en la cual en el presente pues estamos contribuyendo a ello, ¿no? No sé, Raúl, si tengas alguna otra pregunta que a ti te surgiera por ahí.
Bueno, había una pregunta que siempre nos inquieta, si utilizar la madera en la arquitectura es sustentable, por lo que representa a todos. Obviamente nos viene a la cabeza que bueno, viene de bosques certificados, etcétera, pero resulta que en México tenemos el pequeño detalle que te cuesta más caro adquirir la madera certificada mexicana que importarla de Estados Unidos o de Canadá. Pero entonces, realmente el utilizar la arquitectura, la madera es una materia prima muy importante en Europa y más en los países donde ellos desarrollan su arquitectura. En México es un dato muy complejo. Entonces, aquí la pregunta para todos es si el uso de la madera es sustentable y si lo es, ¿por qué?
¿Quién quiere contestar?
I'll take a try. I think David, in his presentation, and a lot of the buildings that Hopkins did, was look for resources and utilization of resources in the particular area that the building was constructed. And certainly architects like Frank Lloyd Wright embrace those principles. In regards to wood, you know, I think it can be a renewable material, and if it's treated like a you know, like a material like concrete or brick that's almost manufactured but farmed, it could be quite renewable for our buildings. And in my presentation, I talked a bit about, you know, biomass and the benefit of using biomass, which is also considered a renewable material and is used quite often in Europe and the UK. So the answer that I have, it depends on the location, and it depends on the technology that's used to create that material in a sustainable way.
Well, I agree with Bruce there. I think as a renewable resource, wood is entirely appropriate in certain locations. I think the note of caution really is its degree of exposure to the weather, but you can design your building to project the roofs and adopt, if you like, the traditional protective measures which will enhance and increase the life of that timber in the use as a building cladding material. I wouldn't suggest it for very tall buildings or buildings where high density suggests that it could be an issue for fire and other complications.
Yo no estoy tan de acuerdo. Sí estoy de acuerdo en parte, porque finalmente en sus países sí existe todo un mercado y una preocupación explícita, garantizada, sobre que es un recurso renovable, y tienen ya bosques que están en proceso, en nacimiento, en desarrollo y para explotación. En México no. Entonces, lo que voy a decir va a sonar un poco fuerte, pero tengo también que expresar mi opinión. Desafortunadamente, considero que el utilizar madera en México no es tan sustentable, todavía. Va a serlo en el momento que tengamos la suficiente producción y todo este círculo donde a nivel nacional hayamos desarrollado todo este criterio de productividad, de producción de árboles para desarrollo, para consumo, y después vengan los demás. Pero si pensamos solamente en utilizar la madera que venga de bosques reciclados, y esto representa tenerle que importar por encima de, no sé, 500 kilómetros, 2.000, 3.000 kilómetros, obviamente esto ya no resulta tan sustentable. Por lo menos, ojo, en el mercado mexicano, como está en este instante, no es tan sustentable.
I don't know the Mexican wood market really precise, but obviously the point is there's no material which is sustainable or not sustainable. It obviously depends on the area and on the detailing in a way. Very difficult for us. I mean, we made a building in Germany, and I tried to use a stone from the area with 20 kilometers. It was 20, and it turned out the stone was much cheaper coming from China. The same stone, yeah. So in a way, we have difficulties that the obvious, logical ideas of sustainability very often are in contrast with our Wirtschaft, our economy, of our other forces of the market at the moment, yeah, and that makes it so difficult. I mean, if there is no wood, I always found that book very nice, Architecture Without Architects, from Rudowski. I don't know who that knows. I think there are only two important books in architecture: Architecture Without Architects and Pattern Language, which gives you an idea of how to organize space in a way. Yeah, and in this Architecture Without Architects, I mean, that was before industrialization, before of means of transportation. it was always completely clear that you build with wood in the area where I come from in Germany, since there are trees and they knew how to handle that. And it was probably logical to build here with clay or with stone, or with the stones lying there and not there. But that is difficult to us today.
Bien, bien, pues podríamos hacer una última sugerencia. Si no hay otra pregunta, Raúl de Portcullis. Bueno, nos gustaría, we would like you to give a message to this new generation of future architects. So just as a kind of professional recommendation for the future.
Have fun.
I guess I would add, have fun and be passionate about your trade, your profession, and also have respect for your fellow person and the legacy, your children as well, and the environment.
And I would just add to that, don't just do what the next guy is doing, think for yourself.
Bueno, en eso sí, todo eso, coincido, pero yo lo que quiero decir es gracias. Muchas gracias a todos ustedes por haber creído en esta propuesta, y creo que hemos logrado el objetivo. Yo me siento muy satisfecho, muy contento, y que ojalá ustedes hayan recibido lo que esperaban. Quiero dar las gracias a mucha gente muy rápido, a Levilla, a Conchita, por supuesto, la secretaria de Marcos Massari, a Dani Fuentes, a Triani, toda la gente de Educación Continua y de la Facultad de Arquitectura, por supuesto al arquitecto Ferreiro y por supuesto a Marcos Massari. Gracias, Alejandro, a todos los moderadores. Es un placer y muchas gracias.
Bien, pues gracias. Y daremos la palabra a Héctor Ferreiro para que…
Bueno, yo quiero comentar que han sido ya 8 años de esfuerzos. Este congreso se repite año con año. Seguramente lo seguiremos haciendo el año entrante porque es nuestro interés que esta preocupación que ustedes pueden notar que no es a nivel local, sino es a nivel mundial, tiene que llevarnos a mejores derroteros en cuanto que hacemos referencia a esta gran labor que podemos tener nosotros los arquitectos, que es la construcción de nuestro entorno. Esto debe de hacerse evidentemente con respeto, y a mí me gustó mucho una frase que quiero destacar de David Selby, que dijo: hay que pensar la arquitectura no solo con la cabeza, sino también con el corazón. Bueno, muchas gracias, y desde luego, como decía ahorita Raúl Huitrón, hay que agradecer también a los moderadores que nos ayudan a organizar el Congreso y nos ayudan a tener puntos de vista que nos pueden desde luego hacer mejorar, y es desde luego también una invitación a que otros profesores se nos unan en este esfuerzo para lograr pues que este ambiente sea el futuro de las generaciones que nos seguirán. Bueno, voy a agradecer al urbanista Enrique Soto por la participación que tuvo durante la primera sesión. Que de alguna manera Enrique está representando al área de urbanismo de nuestra facultad, a la arquitecta Isaura González Godiener. El arquitecto Armando Carranco Hernández, que puso a sufrir al doctor con la pregunta tan interesante que le hizo que si era optimista. Afortunadamente el doctor Sarucán dijo que sí. Al doctor Mauricio Martínez, que en este momento está en clase de sustentabilidad. Al arquitecto Ramón Abud, que representó el área de estructuras, que también fue muy comentado durante todo el Congreso. A el maestro en arquitectura, Alejandro Cabeza Pérez, que sufrió un poquito con las preguntas, pero desde luego le agradecemos su labor. Y finalmente, la Universidad Nacional Autónoma de México otorga el presente reconocimiento al arquitecto Raúl Buitrón. Este es el 8º Congreso y el esfuerzo, créanme, ha sido muy grande. Hemos tenido muy importantes personalidades gracias a esta labor incansable de Raúl Buitrón. Bueno, no me queda más que agradecerles a todos ustedes y hacerles la invitación para que estén con nosotros el año que entra. Muchas gracias y buenas noches.